going to switch on the power. Sini. Then switch on the valve also. Making sure there's no any leaks from the pipes. And then switch power.
Temperature, make sure.
Oh, first we have to make sure the temperature is in ambient temperature, which is 24 degrees. Okay, after that we try to plug all the temperature, all the T into correct numbers. E1, size T2. And then E7, E6. E5. Oh, DOLORYEN.
Lepas tu yang lagi.
After that, we include the stainless steel.
Tu pula. Ujung lagi pula. Ujung.
Ya. Then lastly is T4. After that, we switch it, put it on for power. Then baru switch kita. Okay.
Okay, for the next step, we should turn the power here until 30 watt. Oh. Ini. Okay, once it's 30 watt, we will have to wait until this T2, T3, T4, T5, T6, T7 to stabilize. When it stabilize, you can take the result lah. Why we don't wait for T1 to stabilize? Because T1 will always increase, but we just have to wait for T2, T3, T4, T5, T6, T7 to stabilize. Then we take the data. Okay, that's all. After we get the data, we should repeat the step and change the material on the plate to brass and copper. Okay, that's all.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is KHAIRIL FITRI bin Muhammad Amin and my matric number is B092010Y47. Okay, today I will present the discussion for this experiment. The question 1 for the discussion is calculate the gradient of the chart. what does this gradient represent in the conduction equation? Okay, first we need to create a graph for all three material, which is brass, stainless steel and copper. Okay, this is the graph for the brass, and the right side is the graph for stainless steel, and then this is the graph for stainless copper. Okay, the gradient for all three material is, as we can see at the right table, we have 5 different power. So what does this gradient represent in this conduction equation is, based on the graph, a temperature gradient is a physical quantity that specifies how quickly and in which direction the temperature varies around a certain area. The temperature gradient is a dimensional quantity represented in degrees per unit length on a certain temperature scale. The rate of heat transmission through a medium is proportional to the negative gradient in temperature and the area at right angle to that gradient through which the heat flows according to the law of heat conduction, often known as Fourier's law. Okay, question 2 for this discussion is, use the two furthest reading T1 and T7, the given distance between them, the heater power and the bar area with equation 5 to calculate the thermal conductivity of the metal bar. Compare it with the typical value given in table 1. Explain the cause of any errors of the different value of the theoretical and experimental thermal conductivity. Okay, the formula for thermal conductivity K equal to WL divided by A and multiplied by T1 minus T2. Okay, as we know, the distance between T1 until T7 is 0.12 meter. The heating power that we take is 30 watt. Bar diameter is 0.03 meter. Bar radius is 0.015 meter. Bar area is 7.0686 exponential negative 4. For material brass, we get T1 is equal to 326.4 and temperature 2 is 321.6. Okay, put all this value into the formula and we will get the thermal conductivity for material brass is 1061.03 watt per meter Kelvin. For material stainless steel, the temperature 1 is 320 Kelvin and temperature 2 is 316.9 Kelvin. Okay, the thermal conductivity for stainless steel is 1642.89 watt per meter Kelvin. For material stainless copper, temperature 1 is 327.1 Kelvin and temperature 2 is 322.4 Kelvin. The thermal conductivity for stainless copper is 1083.61 watt per meter Kelvin.
Hi, Assalamualaikum. So my name is NURYN from YATIM. So we will continue with discussion number 3. So the question say, what can you observe from the gradient of the chart for each heat power setting? The slope of the temperature curve on a TL diagram is referred to as the temperature gradient. What the temperature decreases with increasing distance, heat is transferred in the direction of decreasing temperature, and the temperature gradient becomes negative. When we look at the gradient for each heat power level for all the materials, we see that all of the gradient values turn negative as the distance between the heaters increases. When the temperature rises and the distance falls, the gradient becomes positive. So we continue with discussion number 4. At a base fit line through all the results to find the overall thermal gradient. From the overall result, find the thermal resistance R value for the whole bar and then use the thermal resistance in series method to find the R and the K value for the middle section. Use the K value you found from the first procedure for the breast section, each side of middle. So as you can see for on the left side, this is our breast fit line that we get for from the our result. So overall thermal gradient that we get is 915.57 K per M. So thermal resistance formula that we use is R equals to L over Ka. As you can see, this is our thermal resistance for each material, which is for brass is 0.5061 kilowatt. Stainless steel is 0.5950 kilowatt, and the stainless copper is 0.5758 kilowatt. So after that, we need to find the thermal resistance in series. We need to find the R total. So R total is formula for R total is R brass plus R steel plus R copper. So after we add all the information, so we got 1.6769 kilowatt. Next, we need to find the R middle. So formula for R middle is R total minus 2R brass. So we got 0.6647 for R middle. And then after that, we need to find the thermal conductivity for middle section. So the formula for thermal conductivity for middle section is L over R middle times area. And then we got for the thermal conductivity for middle section is 255.40. And lastly, we go to the conclusion. So the question 1, we write 5 conclusions based on the laboratory activities. So first is from this experiment, we know that linear conduction is observed energy in the form of heat being transferred from hot block to the cold block. Second, the graph shows that the rise of distance leads to decrease of final temperature. That means the nearer distance to the heater, the higher temperature increase. When the power increases, the thermal conductivity will decrease. Next, different materials have thermal conductivity. The materials that are known as electrical conductor is more thermal conductivity compared to the materials that known as electrical insulator. And lastly, the different value of theory and experiment is existing because the error when run this experiment. When doing this experiment, students should alert when the temperature data is stable state. When the data temperature is stay with the value, students should take reading fast. I think that's all from me and my friend. Thank you.